Good evening, everybody. Can you please drop a comment whether the screen is visible and the audio is okay? Please confirm if the screen is visible and the audio is okay. One of you please comment down whether the screen is visible or not and the audio is well or not. Okay, I got the confirmation. So according to the polls, I'm starting with the chapter kinematics. Okay, so before starting with kinematics, let's have some basic information about the physics. So what is mechanics? So mechanics is the branch of physics which deals with it is a branch of physics which deals with the motion or the position of the object or a body in space. Space means x, y, z and time t. Okay. Further, mechanics has two parts, statics and dynamics. Okay, so am I not audible to you guys? Okay, okay. So Tully, please check your internet connection once you can join again. Others are saying that it's audible. Okay. Yeah. So mechanics is a branch of physics which deals with the motion and the position of a body or an object with respect to space. XYZ is space and time t. Okay. Further, mechanics has two sections. One is static part, another one is dynamic part. So what is statics? The name confirms that when a body is at rest, and we study about its motion or position or anything related to physics, it will be termed in the statics part. And when the body is in motion, it will be termed in the dynamics part. So it's obvious that some forces must be acting. There will be some acceleration associated with the force, and there will be velocities, displacement. Okay, so static path doesn't have forces and all, or we can say the sum of forces will be zero. That we will see later in Newton's laws of motion. Okay, and then for the dynamics still have two parts. One is kinematics, another one is kinetics. So what is the difference between these two? Kinematics deals with the motion, it's correct. It deals with the forces, acceleration, velocities, and displacement, it is also correct. But it will not consider where the force has come from. Okay, we are not considering why the body is moving. Okay, what forces are acting on the body to move it, but we will be only considering that what is its velocity, acceleration, and position. Okay, and in the kinematics part, that we will study in Newton laws of motion, that why the forces are acting, which forces are acting. Okay, what are the different type of forces acting, normal force, friction force, etc. Okay, so in this chapter, we will be dealing solely with the kinematics part. Okay, and then when we will enter to Newton laws of motion, we will deal with kinematics part and statics part as well. Okay, so the same definition is written here, that kinematics is the branch of mechanics which deals with the motion regardless of the cause producing it. Means that the forces, we are not interested on the forces acting on it. Okay, so there are some points which I want to discuss. Okay, now let's assume there is a car. Okay, there is a car and it is moving with some velocity v, let's say, in the right direction. Now, if I apply brake, okay, the car is moving towards right. If I will apply brake, the car will come to rest after some time. We know this. Okay, the velocity will become zero. So the acceleration will must be in opposite direction to the velocity because I am applying brakes. So if I am applying brakes, the body is stopping. That means acceleration is opposite to that of velocity. Okay. So what does that mean? From point number one to point number two, the car has the motion in the rightward direction. Okay. This was the direction of motion. But what about the direction of acceleration? Acceleration was towards the left. We can see it was a type of retardation, actually, we will study later. But velocity was towards left from this point to this, sorry, towards right from this point to this point. Means that the direction of velocity is in the direction of motion. This is always true. Okay, but the direction of acceleration is not necessarily in the direction of motion. It can be the case, like if we are accelerating the car, if we are pressing the gas pedal, then the velocity direction and the direction of acceleration will be in the same direction, and the motion will also be in that direction. But in this case, in this particular case, the velocity is opposite to the acceleration. So this case suggests us that the direction of velocity will always be in the direction of motion. But by knowing the direction of motion, we cannot judge the direction of acceleration. Okay, we need some different things to judge the acceleration. Actually, it is about force. We need force to know the direction of acceleration. So that will depend, that we will see in Newton's laws of motion. Okay, the second point. So, if a body, let's say there's a particle of mass m, whatever mass it is, and it is having some velocity. We know velocity is a vector quantity. So it is having some velocity. It can be in I cap, j cap, k cap, whatever. So if the motion is a straight line, okay, what do you mean by straight line? That the velocity is not changing its direction. Okay, it can change its magnitude, it can accelerate, it can retard, but its direction cannot change. So if this is happening, the mass m will be moving straight through this line. That's why this motion is known as motion in a straight line, and the another name for this motion is one dimensional motion, or 1D motion in short. Okay, 1D motion in short. Okay, so now if the motion is not straight line, then what it can be? We are actually thinking about that. So let's see. Let's take an example. There is a circle and a body is moving in this circle. Let's say there is a body of mass m moving in this circle, or you must have heard about projectile motion. Okay, a body with velocity v at some angle theta projected from ground. So in this part, the body is moving definitely not in a straight line. Okay, so in this, if I assume this screen as a plane, then there will be an x direction and y direction, right? X and y. So the body can be said to move in x and y both at a certain time. So this type of motion is called curvilinear or two-dimensional motion. Two-dimensional motion. Okay. Similarly, in this case also, you have studied about range. You must have studied range, the maximum height. So the range is in x direction. The maximum height is in y direction. This means that this is also an example of 2D motion. These both of these are an example of two-dimensional motion. Okay. Well, this is very important point to note. We have a concept hidden here. Okay. Let's say a body is moving along this path. Okay. This is the path of the motion, right? And if someone want to know about the velocity, what is the velocity, the direction of velocity of this body? Okay. So let's say at this instant, the body is moving and it has reached this point. Now, if we draw a tangent at this point, tangent to which? Tangent to this curve. This is curve, this is tangent. And if we draw a tangent, now this tangent will show me the direction of velocity of this body. Okay, at any instant of time, if you want to know the direction of velocity, I just need to draw a tangent. For example, at this point, if I will draw a tangent, it will show me the velocity of at this point. Similarly, if I draw a tangent over here, it will show me velocity at this point. So the direction of velocity can be judged by its tangential to the path. That means a tangent to the path can show us the direction of velocity of the body. Okay, what about acceleration? This is about velocity. What about acceleration? So we cannot judge the direction of acceleration from the motion of the body. We have discussed this earlier, that the direction of acceleration, see, the direction of acceleration is not necessarily the direction of motion. We don't know. So what is the thing? So let's assume that there is some acceleration in the direction and we have an angle between velocity vector and acceleration vector. Okay. So this theta is very important. I have three cases. Theta is acute. Theta can be acute. Second, theta is obtuse. And the third case is theta is 90 degree. Okay. So for all these three cases, I have different consequences. See, if theta is acute, let's say I'm drawing a velocity vector here and an acceleration vector here. Okay, with some angle theta. So now this acceleration vector has two components, one like this, one like this. You must have heard about rectangular components in your vector chapter. So I can draw two components of acceleration vector. One is this a cos theta, another one is a sin theta. So I'm not interested in a sin theta because it is perpendicular to the velocity. Okay, I am interested in this a cos theta which is parallel to the velocity. So what are the results? Says that if velocity and acceleration are in same direction, that means this acceleration is helping the velocity to increase. Yes or no? Velocity will increase if the direction of acceleration will be in the direction of velocity. Okay, so if theta is acute, the velocity will increase. This was the concept. What about if theta is obtuse? So let's say there is an acceleration vector a and the velocity vector v. Now we can see that the angle between them is obtuse. Now if I want to break the components of a velocity vector, let's say here If this angle is, let's say, some theta, not theta, let it be alpha. So I have two components of velocity, v cos alpha and v sin alpha. So I'm not interested again in v sin alpha because it is perpendicular to the acceleration. I am interested in the v cos alpha, which is opposite to the acceleration. This means that this time the acceleration is trying to decrease the magnitude of velocity, and hence the velocity will decrease. This is important. Okay. Now third case, theta is 90 degree. We will study this later. It is a very basic thing that if theta is 90 degree, that velocity vector will always be perpendicular to the acceleration vector, and this motion is known as uniform circular motion. We will study this in later classes. Okay. So up till this, everything will be okay. Now I have a question to you guys. Please solve and comment your answers. The first question. You have to find the speed. You have been given the velocity vector. You have been given the velocity vector. You have to find the speed. Comment your answers. Okay. You need to be active. At least you need to comment. It can be wrong, it can be right. You need not to worry about that because we're in the beginning in the course. Okay. So there is a difference between speed and velocity. The first main thing is it is a scalar quantity. The speed is a scalar quantity and the velocity is a vector quantity. Now, what is the difference between these two? The scalar quantities are the quantities for which you need only magnitude to define them. For example, not weight, mass of the body, volume of the body, and what are the vectors that needs the magnitude as well as direction to get defined. Okay, like velocity. So there is a relation between speed and velocity of a body. Speed of a body is defined as the magnitude of velocity. See, velocity is a vector quantity. If you want to find the speed of any body, we need to do we need to do find the absolute value of a vector quantity, right? So if vector v is written as 3 I cap plus 4 j cap plus 5 k cap, and if I want to find its magnitude, then according to the vectors mathematics, it will be 3 square plus 4 square plus 5 square under root. Okay, so if you will find the value, it will be 5 root 2 meter per second. This will be the magnitude of velocity, or it can be said as the speed of a body. Okay, so the speed is the magnitude of a velocity of a body. You should remember these. Okay. Speed is the magnitude of velocity of a body. The next question is, a lift is descending with increasing speed. So what are the directions of velocity and acceleration in the given statement? So let's assume there is a lift. Okay. Now it's descending. Okay. So the lift is going downwards, right? The lift is going downwards with increasing speed. Okay. The velocity of the body or the speed of the body is increasing. That means it's going down. So now we know the motion of the body. The lift is descending means it is going down. And if we know the direction of motion, we can know the direction of velocity of the body. That's why I have drawn the velocity in the downward direction. Okay. And now they are saying that the speed is increasing. The speed will only increase if the direction of acceleration will also be in the direction of velocity. Okay. So the lift is descending with increasing speed means it is going down and its velocity is increasing. So we can say that the direct direction of acceleration and velocity both are in downward direction. Okay. So the direction of velocity and acceleration will be downwards. Clear? So we can define motion in two types. One will be according to the dimensions, that will be 1D, 2D and 3D. One dimensional, two dimensional and three dimensional. I have told you that 1D is a straight line motion, 2D we can say as curvilinear motion, and 3D motion we can take an example of an airplane, okay, or we can take an example of a kite moving. 3D means it will be moving in X, Y and Z axis. Its position will be changing in X, Y and Z axis, okay. So that will be a three-dimensional motion. In our syllabus, we have to see 1D, we have to see 2D. Okay, there will be no questions from 3D, at least in ATC exam. Okay. In another form, we can say a body is uniform or uniformly accelerated or non-uniformly accelerated. Now, what does that mean? Uniform means the velocity of the body is constant. If the velocity is constant, we will say the body has uniform motion. What about uniformly accelerated motion? That means the acceleration of the body is constant. See, uniform means constant. If only uniform is there, then the velocity is constant. Uniformly accelerated means the acceleration is constant. And non-uniformly accelerated, again the name suggests that the acceleration is not constant, it is variable. Okay. So these are the types of motion, 1D, 2D. Okay, now the 1D motion can be uniform, can be uniformly accelerated, and can be non-uniformly accelerated. Similarly, 2D motion can be all these three, 3D motions can be all these three. Okay, so there can be a mixture. We can say one-dimensional uniform motion. We can say two-dimensional uniformly accelerated motion. That will depend on the question. Okay, now there is a concept. Let me move this. Now let's say for a uniform motion, I told you that uniform means velocity of the body will be constant. Okay. And if velocity is constant, we can also say that acceleration will be zero, because the work of acceleration is to change the velocity of a body. Okay. Now velocity is a vector quantity. So if I will write velocity, I am giving an example. Let's say it is 3 I cap, or I can write velocity vector as 4 I cap plus 3 j cap plus 2 k cap. Let's say like this. So when I say that velocity is constant, then two things will be constant, because velocity is a vector quantity and a vector quantity can be shown or can be written in the form of its magnitude as well as in direction. N cap is a unit vector in the direction of velocity. So if velocity is constant, that means its magnitude must be constant and its the direction will also be constant. So these two need to be constant at the same time. Okay, we cannot say like that if only magnitude is constant, then the velocity will be constant. No, that is wrong. Both of them must be constant for the velocity to be constant because it is a vector quantity. So this is the same thing written over here, that its magnitude is constant, and magnitude we have studied just it's a speed, and the direction of velocity is also fixed, or it is also constant. Okay, and now if the direction of velocity is constant, that means the particle will move in a straight line. Why? Because if I'm not changing the direction of the velocity, and I'm also not changing the magnitude, I can change the magnitude for a straight line motion, but if these two are not changing, the body will still move in the straight line motion. That's why it will move in one dimensional motion only. Okay, I have a question for you. Please solve this and comment this down. The answer. Please comment the answer. Just give me a second. Yeah, comment down the answers. You have to just comment 1D, 2D, or 3D. Comment down your answers. Okay, let's see. We have velocity vector. Okay, and it's saying that its acceleration is zero. Now, if the acceleration of a body is zero, the velocity vector must be constant. Okay, and if velocity vector is constant, we can say directly that it is a 1D motion. Okay, many people consider it as a two-dimensional or three-dimensional motion just by seeing this I cap, j cap, and k cap. Okay, let me explain you a bit more. Let's say this is x-axis, this is y-axis. Let's leave this z-axis. Let's say there is a velocity 2 I cap plus 3 j cap. Okay, now if I will draw a velocity vector, it will be like this. Okay, now I said that acceleration is zero. If the acceleration is zero, the velocity vector's direction is not changing and magnitude is not changing. So it will be going like this. A body with mass m started from origin will go along the straight line. Okay. Now you will say that sir, x position is changing, y position is changing, then why it's not a two-dimensional motion? Or why in three-dimensional x, y, and z, the z will also change, then why it will not be three-dimensional motion? See, this x-axis, y-axis, and z-axis are the standard axis made by us. If I assume a new axis like this is an x-axis and this is a y-axis, then according to my coordinate system, nothing will change. Are you getting my point? Only x will change. So if only x will change, it will be one dimensional, y will not change. So if velocity is constant, we need not to check anything else. The body will move in a straight line always, and it will be called as a one-dimensional motion. Okay. Next is the Now we will describe some basic definitions which will be needed in solving the numericals of this chapter. Okay. First one is position vector. Again, I am drawing a y-axis, x-axis, and there is a point lying on this plane. Okay. So in the geometry, you have studied that this point can be addressed as x comma y. Now, if I draw a vector from origin to that point P, origin is this one, 0, comma 0. If I draw an origin, a vector from the origin to point P, then this vector will show me the position vector of that body. Okay, what do you mean by position vector? I am drawing a vector from origin to that point. Okay, so this vector will be defined as a position vector because it is showing the position of the body with respect to the origin. Okay, so now if I want to write this r vector, so this is 0 0 and xy, so I can write x minus 0 I cap plus y minus 0 j cap. So this will be x I cap plus y j cap. This will be the position vector of this point P. Okay, and next is displacement vector. X axis, y axis. There was a body lying at point P and it moved to point Q. Okay, so while moving, it has traveled a curvilinear path. It can be curvilinear, it can be straight, anything. Okay, so point P has some coordinates, let's say x1, y1. Q has some coordinate x2, y2. Point P has some position vector because it is lying at in xy plane. So there will be a vector from origin to that point P. Let's say this is r1. And point Q also has a position vector, let's say r2 vector. Okay, now what is displacement? Displacement is the difference between the positions of a body, not the difference, but we can say the change in position of a body. Okay, so now the body has reached the point Q. It was initially at point P. So this was the displacement of the body, the straight line drawn from the initial point to the final point. This is known as the displacement of a body. I am writing it as delta S vector. Okay, so now from the triangle law, you can see a triangle over here. Okay, a triangle like this, this vector and this vector. So from triangle law we can say that r1 vector plus delta s vector is equals to r2 vector. So delta s vector I want to find is will be equal to r2 vector minus r1 vector. Okay, so this will be known as the displacement vector from point P to point Q. Okay, displacement vector from point P to point Q. Now, if you want to find the exact value in I cap, j cap, and k cap, put the values of r2 and r1. Okay, so r1 will be x1 I cap plus y1 j cap, r2 will be x2 y cap plus y2 j cap. Put the values and you will get the exact value. Okay, now let's say a body started from point A, reached point B through this path or through this path or through this path. So in all the paths, the distance will be different. Why? Because distance is known as the length of the path covered by the body. So this is the length here, this is the length here, and this is the length here. All the lengths are different. That's why the distance will be different from A to B. But what is the displacement? I told you that if you join these 2 points, the starting point and the ending point, this will known as the displacement of the body. So 2 things or 3 things are there which differentiate between distance and displacement. Number 1, distance is a scalar quantity. It can never be negative. Okay, it can never be negative. And displacement is a vector quantity, can be 0, can be positive, can be negative. Okay, here in this example, the displacement was the shortest path and there were 3 long paths over here. Now if I say that a body moved from A to B along this path, then the distance is this only and the displacement will also be this. Why? Because it has moved in a straight line. Okay, So in this case, the distance will be equal to the displacement of the body. But in this case, displacement was less than the distance of the body. Hence, combining these two results, we can say that distance is always greater than or equal to the displacement of the body. Now, since displacement can be negative, I am adding a modular sign so that we can compare between two positive values only. Okay, so the distance will always be greater than the displacement of the body. Keep this in mind. Okay, there is a concept question over here. The particle is moving on a straight line with some velocity and some acceleration. The distance will be equal to displacement. You have to tell that whether this statement is true or false. Just comment capital T or capital F. You can either comment here. If you don't want to comment here, you can comment on Telegram channel also. Okay, so Kohli says it's true. Anyone else? So let's say there are 2 points A and B. The particle is moving on a straight line, so I have drawn a straight line from A to B with some velocity and some acceleration. Okay. So let's say the body has started with this velocity vector and this acceleration vector. Okay. So in this case, the body will be keep moving in this line till it reach point B. So what happened? The distance is equal to the displacement. But let's assume another case. This is point A, this is point B. Again, the velocity vector is in this direction, but this time the acceleration vector is in this direction. What will happen now? Now the body will start moving along this line because it has some velocity in the right direction. It will keep moving in this direction, but the velocity will be decreasing. Why? Because acceleration is in opposite direction. So the velocity will be decreasing. At some point of time, the velocity will become zero. But since the acceleration is towards right, the body will turn back. Okay, the body will turn back and move backwards towards it. So in this case, the distance will not be equal to displacement, right? Because the displacement will decrease. Okay, let's say it has reached here. So distance is this much. This much is the distance. But what about displacement? It is only this much. Okay, so this statement is false. Why? Because we cannot say always that if a body has some velocity and some acceleration, the distance will be equal to displacement. No, it is not always true. Okay, it can be true in some cases, but cannot be true. Okay, I hope you got this. The direction of velocity, until and unless we don't know the direction of velocity and acceleration, we cannot judge about distance and displacement. Okay, because it will depend on that fact only. So now, since we have studied about distance and displacement, we have some further definitions related to these two values. So what is an average speed? Let's say a body has started from A to B, okay, and it is moving like this, okay, not in a straight line, but in a curvilinear motion. So in this case, there will be some distance and some displacement. So this is the displacement, the straight line, and this path covered is the distance. Okay, so what is average speed? Average speed is defined as the ratio of the total distance traveled, not the displacement, distance traveled to the time taken. Okay, this is the average speed. We can write it as like this, average speed. Okay, so again, this is a speed, so it will be a scalar quantity. It cannot be vector. Okay, we can see that distance is a scalar, time is a scalar. So this is a scalar quantity. And the SI unit will be meter per second. The next is average velocity. So in the above case, we have used distance to calculate speed, but if we will use displacement to calculate speed, then that speed will be known as average speed, sorry, average velocity. So now since this is a vector quantity, displacement is also a vector quantity. So a vector divided by a scalar, it will be a vector quantity. Okay. So average velocity will be displacement upon time, and its SI unit will also be meter per second. And you can show it like this, V vector with average. This is V average. Okay. Now let's say this is position time graph of a body like this. Okay. Position time graph of a body. A body was started from this point. This point is, let's say, x initial, and the time was 0 here, and it has reached some point x final, and the time was something t dash, let's say. So if I join these 2 points, then this will be known as displacement. I know that the difference between the final position and initial position is known as displacement. And if I divide this value by time, I get average velocity, displacement upon time. Okay, now if I reduce the distance between, or the separation between these two times, now I am calculating from t1 to some time, let's say t2. Now this will be my displacement. Okay, and then I will be dividing with the time, that is t2 minus t1. Okay, the displacement is d upon t2 minus t1. Again, if I still reduce this t1 and t2 gap, I will be calculating about these 2 points. Okay, so by reducing, so if I came to a point that the distance between these two gaps is just equal to 0, then the separation between times will be negligible. That means that I am calculating velocity at a certain instant. Okay, so that is known as instantaneous velocity, and the instantaneous velocity can be defined as the slope of xt curve at that point. Okay, so that will be dx by dt, let's say, if it is in x direction, or dy by dt if the body is moving in y direction, or dz by dt in z direction. Or randomly we can say, I'm not writing these all, I can randomly say the change in the rate of change of position vector. The position can be in x, can be in y, or can be in z direction. So that is the concept behind instantaneous velocity. In limit form also we can write that displacement upon time with limit of time tending to 0, delta t tending to 0. I am reducing the separation between these two times to just equal to 0. That's why I'm using this limit. So this is also equal to the average instantaneous velocity of the body. Okay, you can write it as vi. That will show you instantaneous velocity. The next is average acceleration. This is very simple. Let's say there are 2 points A and B. The body has some velocity v initial at this point and v final at this point, and the time taken to reach from A to B is, let's say, t. Then the average acceleration is defined as a bar is equals to the change in velocity vector upon the time interval in which the change has taken place. That means the final velocity vector minus the initial velocity vector upon the change in time, or the time taken to change these values. Okay, so this is known as average acceleration. The SI unit will be meter per second squares. Okay, the same will be here. Okay, average acceleration, yes. Next is instantaneous acceleration. Again, if I reduce the time to zero, I want to calculate the acceleration at a certain time, at an exact time, then that will be known as instantaneous acceleration, and that will be equal to dv by dt, rate of change of velocity. Okay, so again this will be meter per second square. And again we can write in limit form, limit of time tending to zero, delta v by delta t. This can also be written. Okay, now let me create. Okay, there is one important point which is noted over here. Let's say a body is moving in one dimensional motion. Okay, so the body will be moving in straight line. Now there will be velocity associated with the body, or acceleration associated with the body, and displacement associated with the body. So if it is moving from A to B only, the velocity can be either in this direction or in this direction. Similarly, the acceleration can be in this or this direction. The displacement can be in this direction or in this direction. What I mean to say is that if a body is moving in a straight line, then see here, the displacement, velocity, and acceleration, these all can be treated like a scalar. But why and how? By assuming one direction is positive and another is negative. That means if one of the direction is positive, सब चला गया, सब चला गया. So if motion is one dimensional, then we can treat vectors as a scalar if we assume one direction to be positive and other to be negative. Okay, let's say that the body is moving towards right with some velocity 2 meter per second, and it is in a straight line motion. And if I apply a brake, so the acceleration will be in opposite direction. So whatever be the value of acceleration, let's say 1 meter per second square, that will be treated as a negative value. Why? Because I am saying that I am retarding the body, so its direction will be opposite to the direction of velocity. And if I assume this direction to be positive, opposite direction will be negative. Okay. So in this way, we can treat vectors as a scalar if we assume one direction as positive, other as negative, only in one dimensional motion. Okay. Remember this thing, this can be only used in one dimensional motion, not in 2D or 3D. Okay, in 2D and 3D we will study later. So here is a question. So we have x coordinate as a function of time. Okay, with time how the position of a body is changing, that we know, and we have to find the average velocity in this time interval. Okay, so let's say this is xox plane, x plane, and there is a body moving in x-axis. Okay, now what I'm saying is, with respect to time t, this x is changing. Okay, so at time t equals to 0, if I put the value at this point, what will be the initial value of position? That will be 2 into 0 plus 4 into 0 minus 6. So it will be x equals to minus 6. So this is at t equals to 0. At t equals to 2, if I put the value over here, x will be 2 into 2 square plus 4 into 2 minus 6. So it will be 8 plus 8 minus 6. It will be plus 10. This is at t equals to 0. So now, what is the displacement of the body? At t equals to 0, the body is here. At t equals to 2, the body is here. This is the displacement of the body. S. Okay, the final value minus the initial value. So how can you find the displacement? If this is plus 10, this is minus 6. The displacement is how much? Final value minus initial value. That is 16 meter. This is the displacement of the body. And if you want to find the average velocity, that is known as displacement upon time, will be equal to 16 upon time taken is from 0 to 2 seconds elapsed. So this will be 8 meter per second. This will be the average velocity of the body. Okay. The next question. This question I have seen in ATC previous year exam. Okay, this is one of the PYQs. So there is a clock. It's second hand. Okay, we have it's second hand. I'm drawing a second hand over here, and the length of the second hand is given as 2 centimeter. Okay, we have to find the average speed and the modulus of average velocity, means whatever be the average velocity, I want to give the answer in positive value, and we have to find the average speed and average velocity in 15 seconds. Okay, so we know that a second hand completes its one complete revolution in 60 seconds. Okay, so in 15 seconds it will reach from initial point to here. Okay, so this is the initial position of the second hand, and this is the final position. That means t equal to 0 and t equals to 15. Okay, this is also 2 centimeter. The length of the hand will not change. So first we will find the average speed of the body. So average speed is defined as distance upon time, right? So first of all, you need to find the distance of the body. So distance is the path covered by the tip. This is the tip. So this is the path covered, right? This is the path covered. That means the length of this arc. Okay, let's say it is L. So the value of L is given by how much? This is 1/4 of the total circumference of the circle. Yes or no? So 1/4 of total circumference is 2 pi r. Okay, so that will be pi r by 2. This is the total length or the distance covered by the tip of the hand. So that will be pi r by 2, and the time is t, whatever it took. So pi, let it be pi only. R is the length of the hand. This is the radius of the circle also. So I am putting this not 2 centimeter, we have to put in meters. So 2 into 10 power minus 2. Why? 100 centimeter is equals to 1 meter, everybody knows. So 1 centimeter equals to 1 by 100 meter, that is equals to 10 power minus 2 meter. So that's how we use here. 2 into t. Time taken, it took from 2 t equals to 0 to t equals to 15. So it took 15 seconds. Okay. So you can solve this value. It will be pi by 15 into 10 to the power minus 2 meter per second. This is the average speed of the body. Okay. Now, what about average velocity? For average velocity, I need what? Displacement, right? So this is the displacement, initial position and final position. If you connect it with a straight line, this is the displacement of the body. Now you can see a triangle over here. There is a triangle. Okay. So for this triangle, the hypotenuse I don't know, and I know this value 2 and 2. So I can write hypotenuse is equals to under root of 2 square plus 2 square by Pythagoras theorem. Okay. So that will be 2 root 2 meter, not meter, it's centimeter. Clear? So now if I know the displacement, I can find the average velocity of the body. That is the displacement which was 2 root 2 into 10 to the power minus 2. Why I am doing so? Again, to convert it to meters upon the time taken is the same. So this is the difference between these two values. Okay, average speed and average velocity. The distance or displacement are never the same. If anybody of these two changes, the values of these two values will always change. Okay, so this was the displacement here and this was the distance here. These are the differences between these two. Okay, now okay, uniform motion. Okay, we have defined uniformly circle. We have initially defined two types of motion. One with respect to dimensions, which was 1D, 2D, and 3D, and another one was uniformly accelerated and non-uniformly accelerated. Okay, so first we are starting with uniform motion. What is uniform motion? I told at that time that if acceleration of a body is zero, that means velocity will be constant. Now, if acceleration is zero, that means the acceleration vector is zero, and if velocity is constant, that will mean the velocity vector is constant. Okay, so now if a velocity vector is constant, means the magnitude and direction both are constant. Okay, neither the magnitude is changing nor the direction is changing, and definitely it will be a 1D motion. Okay, we have defined this earlier. So for this, displacement can be positive, can be negative, that will depend on the direction of the motion, but what we can always say is the distance will always be equal to speed, which is constant, into time. Okay, the distance will be equal to speed into time. And displacement, again we need to find, for displacement, let's say the body is at x equals to 0, at t equals to 0, and if the velocity is constant, magnitude and direction is constant, means it is moving in a straight line without turning back. Okay, if it is not turning back, then the value of displacement will always be equal to distance. Now I am taking the mod sign. Why? Because I want to ignore the negative value. Because distance will never be negative, it will always be positive. So the displacement will be equal to distance in this case. Okay. Now there are three special cases. Point A, point B. It is said that a body has covered two equal distances in some time. Let's say the velocity v1, velocity v2. So from A to C, it has traveled a distance d with some velocity v1. And from C to B, it has traveled a distance d, same distance with velocity v2. And we want to find the average velocity from A to B. Okay, the average velocity, or let's say the average speed from A to B. Okay, so for average speed, we want to find the distance upon time. The distance we know from A to B, the distance is 2d. Everybody knows this d and this d. But what about time? Let's say from A to C, the time taken is TAC, and from C to B, the time taken is TCB. Now we want to find this time. If the velocity is constant from A to C, if the velocity or the speed is constant, then we can write the distance is equals to speed into time. From here we can write TAC as d by v1. Similarly, from C to B, this was from A to C. From C to B, this distance is v2 into TCB. So TCB we can also find as d by v2. Now we will put these two values in this equation. So it will be 2d upon d by v1 plus d by v2. So this will be 2d upon, if I took d as common, it will be 1 by v1 plus 1 by v2. I can cancel this 2d. If I will take the LCM, it will be 2v1 v2 upon v1 plus v2. Okay, so what is the thing? The thing is, direct question can come like this: if the distance is same and the velocities are v1 and v2 from A to B, in between is C, then we can directly say that the average speed is equals to 2v1 v2 upon v1 plus v2. Okay, this was the first case. Second case will be again the same point A and B. Now the distance is not same. Let's say it has traveled some distance d1. Okay, we don't know d1. Let's say this is 0 time, this is t time, and this is half time. That means if it has traveled 0 to t seconds, then half of the time he has traveled A to C, and half of the time he has traveled from C to B, with again some velocity v1 and v2. And now we want to find the average speed of the body. Okay, again it will be distance upon time, distance upon time. Let's say this distance is d1. This distance is not same in this case, but the time is same. The time to travel is same. Okay, so now this will be d1 plus d2 upon total time. Let's say it is t1 plus t2. Okay, so we don't know what is d1 d2. It's only mentioned that velocity is v1, velocity is v2, this time is 0, this is t by 2, and this is t. Okay, this is the only thing which is mentioned over here. So for d1 we can write, in this case, since it is a uniform motion, we can write d1 distance is equals to speed into time. Okay, and for d2 we can write d2 is equals to distance equals to speed into time t by 2. See, from t by 2 to t, the time taken is t by 2. From 0 to t by 2, the time taken is t by 2. So I'm putting the values here. It will be v1 into t by 2 plus v2 into t by 2. Okay, and t1 and t2 is how much? It is t by 2 plus t by 2. The time taken are same. Hence, if we will take t here, 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 common and cancel out, it will be v1 by 2 plus v2 by 2 upon 1 by 2 plus 1 by 2 is how much? 1. Okay. So this will be v1 plus v2 by 2. This is the direct formula. You need to remember this, that if a body has moved from A point to B point such that it has traveled two distances with same time. This is t by 2 time taken, and this much is t by 2 time taken. Then we can say that if this velocity is v1 and v2, then we can directly say that the average velocity from A to B is v1 plus v2 by 2. Okay, this is the direct formula for this. Now, these are the three special cases which we are talking about. In the next class, we will start with this chapter only. We will start with one-dimensional motion with uniform acceleration. That means the case of free fall and all these. I'm giving you examples like if a ball has thrown up with some velocity u in a free fall, or if a ball has thrown from some height, let's say h, then what will happen, how much time it will take, what will be the velocity at every point. Okay, we will study all these in the next class. Okay, you can post your doubts on the channel, and I will try to solve them. You can share your feedback in the comments.